Stop thinking about math like human. You know PEMDAS, your computer doesn't. When a compiler sees 2 plus 2 times 5, it runs into a massive bottleneck. Today, we're unlocking the computer's secret language for solving math, postfix and prefix notation. I'm going to show you how to quickly convert any complex expression into these formats, which removes the need for parentheses and makes your computer's jobs 100 times faster. Let's dive in and start converting. So, what exactly are we talking about? There are three main notations. The first, Infix, this is what you and I use every day. The operator, like the plus sign, is in between the operands A plus B. Next is postfix, which also called reverse Polish notation. The operator comes post or after the operands of A, B plus. And finally, prefix. Prefix or Polish notation. You guess it, the operator comes pre or before the operands A plus B. So, A, B, this is the operator and the operands. Here are the 4 key reasons why the computer prefers that. First is no ambiguity. The biggest reason is that this conversion completely eliminates ambiguity. In Infix, an expression can be interpreted in multiple ways unless you have extra rules. Postfix and prefix remove all that. The structure itself is the definitive instruction set, making it impossible for the computer to misinterpret the math. Second, no PEMDAS required. Because the structure dictates the order, we completely remove the need for PEMDAS or any complex precedence rules. The computer doesn't have to post and compare the priority multiplication versus addition. The conversion resolved the entire problem, ensuring the processing flow is simple and uninterrupted. Number 3. Efficient evaluation with stacks. This leads us to efficient gain. Postfix and prefix are extremely efficient to evaluate using a simple data structure called stack. The computer uses one continuous pass loop. Read an operand, push it into stack, read an operator, pop the 2 items at the top, calculate, and push the result back. This simple sequence of push, pop, and calculate is the single fastest way a computer can solve expression. Number 4, compiler design. This efficiency is why they are crucial in compiler design. Compilers, which turn your human-readable code into machine instructions, need to work lightning fast. They immediately take your Infix math and convert it to postfix or prefix internally, ensuring every calculation is processed in the simplest, most robust, and fastest way possible. So let's start an example, Infix to postfix. Here is our starting Infix expression for this tutorial, A plus B times C. The first rule, just like in regular math, is to process innermost parentheses. So, we're going to focus on the A plus B. Now for the move, since we're converting to postfix, the operator moves to the end of its operands. So the plus sign moves to the end of A and B, giving us AB plus. Now we treat the entire AB as a single unit or a single operand. The next operator we have to deal with is the times sign. Our 2 operands are AB and C. And we do the exact same move. The times operator moves to the postfix position, which is at the very end of its 2 operands. The final postfix expression is AB plus C. Okay, that was postfix. Let's try it again, but this time we'll convert from infix to prefix. So we use the exact same starting expression to compare A plus B times C. So and the rule is the same. We start with the innermost parenthesis first. So we will look at A plus B. Now for the move, we're converting to prefix to the operator moves to the front of its operand. The plus sign moves to the front of A and B, giving us plus AB. And for the final step, we treat plus AB as our first operand and C as our second. So the times operator moves all the way to the front of the entire expression. Our final prefix notation is times plus ABC. So let's look at our final summary. So we started with the infix expression A plus B times C. So our postfix result was AB plus C times. And our prefix result was times plus ABC. So do you notice how the operands A, B, and C stays in the same order relative to each other? Only the operator moves.
And that wraps up the full conversion process. Before you go, let's lock in the 3 essential rules you need to remember. Infix, postfix, and prefix. These are the 3 essential notations that determine how efficiently a computer executes your code. If this video helped you understand how your code works under the hood, please hit that like button and subscribe for more coding and computer science tutorials.